Hello everyone and welcome to We Meet at Digital Days. My name is Lisa Richter and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Switch Insider, what makes a switch a quality switch. Our speaker is Götz Schattmann. He will hold a presentation and he will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out a survey and help us to improve the event. You will receive the link to the presentation in the next few days. The recording will be available at our website shortly. So now I will hand over to our speaker and I wish you an exciting presentation.
Thank you, Lisa, for your kind introduction today. And I would like to welcome all of you here to our webinar. And let's start. So the question of today I would like to save us the time and read down a long agenda. And I come right across with the question, what makes a switch a quality switch? And just because you're here today, I suppose that maybe once or maybe more than only one time you faced a problem with an electrical switch. Was it just overloaded? Maybe it did burn, or did you get an electrical shock, or did it just do nothing? However, it failed and it did not what you expected it to do. So was that already a quality issue? How can you choose the right switch for your future application? So the goal of today is to give you a few important points to consider when choosing the right switch. What is a switch? Or let's say, what does a switch? Well, of course, you all know it. It's a control element to make or break an electrical circuit, like light on, light off, light dark. Very easy. It's an electromechanical component, which means it must be operated mechanically, whether if this is done by hand or by any other moving part of a machine, like for example, a garage door, when it comes to end position. Of course, there are also switches that are not mechanically operated, like solid state relays, but this is not what we're going to talk about today. So some of you may think it's just a switch, a minor component on my application. A switch is made of metal and plastic, so what can be so complicated? Well, there are switches of all kinds and shapes in the market. And at the end, it's still all about making or breaking the electrical path. That's what we learned. But then, of course, there are a lot of other details to consider. Like you have the electrical points, like voltage, the current, resistance, mechanical, like the force that you have to apply, the haptic, how it feels when you press on the switch, the number of mating cycles you want to achieve in the total life of this appliance. Then, of course, the environment, what's the temperature around, moisture, vibration, shock, and so on. So far, this still sounds pretty easy to cope with. Now, if you go into detail, many further requirements may apply depending on the application or on the production process as well. Like there are IP class, this is very popular, of course, to ask, like washability, type of electric load you use, the bounds, soldering process, or even manufacturing process. Like if you have THT, SMD, if you have a double wave, or even hand soldering. Then if you use your appliance in a critical environment, like if there's only dust or dirt around, or even aggressive chemicals or explosive gas or whatever. So even temperature makes sense, and maybe you have special requirements in terms of safety or some kind of conformity. So we will have a closer look on these points. And yeah, am I right? Do you expect quality like this? These are pictures that we observed on the plating capabilities after a salt spray test, which is one of our extensive tests. Over the past 10 years, our lab at Würth Elektronik, we did observe many different products from the market. Even customers gave them to us to examine what went wrong with their products, and we were sometimes astonished of what we found out from the market. Although every manufacturer express on their quality, it seems that the wording quality sometimes have different definition. So here are some more images. This is what some parts will look like after a full load test or endurance life cycle test. And here we can see a clear burn down of the contacts, or the plastic was melting. And those fail situations can for sure cause to functional failures, as this is obvious here. And maybe the application can burn, or the component or the whole appliance can start to burn. And this is, of course, what we need to avoid. So not only to observe the metal parts, we looked at the plastic parts as well. And we found some melting, like you can see here, even the knob, the actuator melted, like a discoloration, which is not so harmful, but it's even not nice. And you see here the tear of the rubber from its original position. It's not function anymore. So how can you determine a quality switch just when you compare a data sheet? Yeah, the products look more or less the same. The data sheets showing the same specifications. Some footprints are even compatible, so you can just interchange them. And some are more costly than others. Some are on the same price level. So indeed, this tells you this is not an easy task to find out what's a quality switch from these points. So at the end, you need to trust your switch provider, your manufacturer, and sorry to promote ourselves at this point, but this is what I know, what we do at Würth Elektroniks, and we have identified some factors to avoid these unacceptable influences. So very important, of course, is the choice of the basic materials, like not only the metals, but also the plastics. Then, of course, you need to have adequate plating for good current leading. Then you have to pay regard on the molding precision, as every component is fitting together, and ensure a stable production manufacturing process. And it's important to monitor and control the process and the final products, and this is done by testing. Test will tell you that you have to do a lot of tests. The most of these points, you don't have insight what your supplier does if you just buy a component. Therefore, you have to dive deeper and ask for a proof. And here's an overview of the most common tests that should be performed by any switch supplier in the world. Should be mandatory. But still, you have to look closely on the results and know how individual points are to be interpreted. Sometimes the devil is really in the details. Now, if you look on the list here, like point 1, it's about environmental test specification according to the international standards here. And the durance, how long this test is taking, like temperature resistance, thermal shock, temperature, and so on. Then number 2 is about soldering. How can the component be soldered? Whether it's SMD, we have for us a 5 times reflow test that a component has to run through, and for THT at least 3 times. Wave soldering without any negative aspects. Yeah. Then number 3 is about shock and vibration. And when it comes to vibration, as you know, you can destroy everything with vibration or shock. And number 4, this is a point where we are absolutely proud of, is the operation lifetime test and the end of life test, which is so important, and where the way of testing can be so different. This is what we're going to show you on a further slide. We are testing our switches under full load always, but see this in a moment. At Würth Elektronik, we can give you full insight of all these reliability test reports. Just ask your local sales engineer and or your colleague, so we can provide this information to you. So additional quality testing, what further tests are useful to ensure good quality? We saw the salt spray test images before. So after this test, no signs of corrosion is allowed. Then the mechanical test, the static load test, is a 500-hour observation of switches that are likely to operate for a very long time in the same position, like a dip switch or a slide switch, or even a micro switches that are pressed or set to its position a very long time, and we test them under full load, how they develop there over the time. End of life is clear after how many cycles the switch is likely to break down, but not to compare with the life cycle test. This number of life cycles is what is guaranteed in the data sheet. Then we have the special pick and place test for components that are some kind of tricky to handle due to its geometry or for the final destinated position, like for example an edge mount switch, which could fall off the edge when of the PCB during manufacturing. So we want to ensure that everything is safe here. The UV test, so for ultraviolet, of course, is a sunlight, is done in a sunlight simulation chamber, important for switches used in the sun, like a rocker switch, for example, for an appliance that's used outdoors. And yeah, last but not least, flammability tests like glow wire are really important, and in some cases are mandatory, like UL. This will give you just an idea of what is all behind the scenes. And there are even a lot of more tests, since we did not mention all the initial electric tests that are shown in the product specifications. So here's a point. Here's some issues we found when we compared with other switch suppliers. Like we did not took any pictures here, not to blame anyone, so we call it manufacturer A. And we really found on the data sheet the takt switch was rated for 50 milliamps at 12 volt, which is very, very common. We have the same thing here. And for this manufacturer, the life cycle test was defined at 5 milliamps and at 5 volt DC for 1 million cycles. So the question is, how long is this switch going to last under the full rated load? So you have no idea out of the specs. And another point, manufacturer B, we call this, slide switch was rated with 20 milliohms initial and nothing else. So what's the contact resistance gonna be after full life cycle test? Is it going to increase, or what is going to happen here? So at Würth Elektronik, we specify all ratings under full load, as mentioned already, and all specifications rated will be achieved after the full number of life cycles. If there are exemptions, then we show them directly on our datasheet, like you can see here, the initial contact resistance and the afterlife contact resistance, just as an example. So here's one more test that I mentioned before. It's a glow wire test, just to give you an impression what it looks like. This is the samples before, and this is the what they looked like after test. You see they are destroyed, of course, yeah. And this is how it's going to be tested, just to give you an impression. Here's the sample, and this is the glow wire, and this is going to run into the plastics, and it shall not ignite or burn for a longer time. So this is just to give you an idea. So coming to quality points, here's some points that I would like to mention. Takt switches use a snap disk for its momentary function. So this is that one. Means it jumps back to its initial position if release after you've pushed it. Snap disk can be made of stainless steel, and stainless steel have a proven higher reliability than, for example, copper alloys. So you can achieve more mating cycles here, and also it's better protected against corrosion and oxidation. Another point is the contact plating. So just to name the most relevant platings here. Silver is very good for switching contacts. It's the best conductor anyway, and it's really widely used. It has a low tendency to generate sparks or electrical arcs, especially when you're breaking a contact, when you open it. And therefore, contacts are not welded together, and they are not burning down. Therefore, silver can be used in power applications as well as for low power. And gold, of course, many swear on gold contacts to have a safe connection all the time. Just imagine there is a switch that is pressed only once in a lifetime, like for example, an alarm switch or a dip switch that is in the same position over years, and then you want to switch it only one time, so it should work at that point. However, the plating thickness at the contact point need to have a certain thickness, and you need a nickel underlayer. All these points that are costly. So it depends on the application and maybe a little bit of faith. Most of our switches use silver, only a few have gold contacts. Another point is the IP rating. So if it comes to IP, then IP67 often is requested from engineer just to be on the safe side to protect everything. Yes, of course, a waterproof switch is protected against the ingress of dirt or anything else that could affect the function of the contact resistance of a switch. But the solder terminals, if this is sealed here, but the solder contacts, they're even free on the PCB. So it has nothing to do with waterproof in that case. However, very often IP67 is not really necessary. Most of the makers of waterproof appliances need to seal the complete assembled PCB or housing anyway. So who really needs IP67? And this is what we find here. If you have a washing process for your PCB, then IP67 could be the right choice. even for appliances that are used in harsh environments, and if an equipment makers want to have really additional protection. For PCBs that need to be potted, so if potting material like the rubber or silicone is going to go around here, you need to make sure that it cannot run inside of the switch. So therefore IP67 is good. And one point is if you want to assemble your component or your PCB in a vapor phase. Therefore, it can be really a good idea to use IP67 components. Washable, there are also washable switches outside, and washable does not mean the same like IP67. Especially washable components are not made to be submerged into liquid. And for a washable definition, we bring with all the components that we defined as washable. So you will find this directly on the data sheet. So take care for that, and you can also select this over our web page if it comes to our components. Quality points. Another one is force in trouble. Well, this is more or less about the selection, not really quality point. The quality comes when you feel it, yeah. And the higher force actuation offers a better haptic feedback, means also it's clicking stronger, but also it means if you use a higher force, then you have to expect lower life cycles. Like in our standard program, we offer force type of 160, 260, 360 steps of gram force that you have to apply to activate the switch. And the life cycles may be, for example, if you have for the lowest gram force type, you have a 1 million travels life cycles, then you have to expect 200K for the highest pressure. So there are also short, mid, or long travel types available, and this is always what the customer wants to have. It's a very personal perception. The travel is from 0 to 0.3 millimeter is what we call short travel. Mid is from 0.3 to 0.4 millimeters, and over 0.4 is what we call a long travel. And really it's depending on the personal preference. For example, our IP67, like shown here, has a longer travel because it has a softer actuator made of silicone, and therefore the travel is a bit longer. So just an idea here, more or less a hint, mechanical end stop. You should, of course, not exceed further more force than the over travel foot. Means if you're at the end position, no further force should be applied to the switch, because too much static pressure, of course, can harm your switch. Maybe there's a chance if you use a cap on top here, or what kind of actuator sits on top of it, that you build a mechanical on-stop that you cannot press it any further. So I call this application type of electric load. So here we focus on this. You should know what kind of electric load you want to switch. If it's not only a clearly resistive load, means it could be mainly inductive, or like a coil of a relay, for example, yeah, or capacitive load, like for a capacitor or incandescent lamps, or it can be a combination like motor load, for example. And on the switches, like these switches we have shown here, you can find the appropriate value that's reasonable for here. So I don't know if you can see it right. There are two different values for DC and for AC. And this is the same here. Rated current resistive, motor load, and the different values in terms of currency and voltage. So this is what you have to take care about. Also, application, use the right switch for the right purpose is the hint. And the question is if you can use a takt switch like a detect switch. So it means it's maybe in the position of an enclosure and it's pressed all the time, and like a temper detection. And if somebody opens unwanted the enclosure, then it gives an alarm. Well, this is not recommended because takt switches like this one are not designed to be activated over long time. So therefore, you really should focus on a detect switch. And another hint is about the layout dimension. It could be a good idea to have a second source or a second type qualified for your application. And why not try to run multiple layout like we did here. The black one was the initial layout, and we said, okay, this one is very close to it. Just widen the tabs a little bit, about 0.2 millimeters, and then you can use the other one for replacement. So just about quality, also documentation can be a point of quality. So what you should get, or what you can expect at least, is a fully technical description with clear readable data sheets. I've seen so many data sheets that were so terrible. And I guess you too. And you have to need to have good drawings or measurements shown in there, like as well. It's fine if you have 3D files and layout files, like for your layout software. Then you need to have the reliability test reports if you want to look deeper, and the precaution guide, just that tells you how to handle this device, and a solder profile, of course, and the packing information. It's important for your processing and for the production. Then further material compliance information, like full material declaration if it comes to your technical information for your final product. Also, you need to be compliant for CE if you work in Europe. Then ROS and REACH are mandatory, like in the latest version, ROS 3, and maybe also China ROS, and what else is in the market. And also official statements about halogen-free conflict minerals, California proposition, and what else is out there requested. And then, of course, in case of a problem, what kind of support can you get? Well, here's an example, and yeah, we're running out of time, but I still want to raise this. This was one from one of our Netherlands customers who had a problem with his supplier, and the actuator of the dip switch that they used was very easy to set up in the middle position, like here. And for a dip switch, you only have two positions, but no middle position. That's not defined. So the contact resistance also raised, and based from this description, Würth Elektronik decided to support the customer with a full analysis of the incremented parts that were, of course, not from Würth Elektronik. And so first we made a CT just to look inside without destroying the component, to see what can be the possible root cause. And based from this, we assumed that the force resistance area came only from the bulbs here, from the area in the blue circles. And over the time of use, so we performed an operation live test, and the test result was really as expected. After many live mating cycles, the buckles on the actuator were fricted. You see them flattened here, and therefore they lost the height, and the height was meant to bring the pressure down to the contacts. That's why the contact force was not high enough anymore, and the contact resistance raised. So the buckles were fricted, as I mentioned, and the force on the contacts therefore got smaller, and we provided this test report to the customer for his further consideration, and of course he is still a customer with us today. Also, in case of a problem, what support can you get? You should have contact to your local sales engineer or even a field application engineer. At least you should be supported by the TQM of your supplier with technical analysis, observation, measurements, just to scrutinize what is the real problem. Then if we found it, or if it's found, if it's minor, you should get a 4D report, or at least if it's a real problem, then 8D report or equivalent, so that at the end you have a solution. So that brings me to the conclusion that we found out it's not so easy just to compare switches from all over the market. I could give you a list of technical points now, like voltage, life cycle, push force, and so on. And this is what you know by yourself. But even if switches look so similar, the quality can be really different, and it's hard to find what's the case for that from the outside. Of course, there are major technical specifications that had to fit together. To check out the supplier and to ask for further information, like test reports, as I mentioned, the standards that they use that are relevant for your application, also that has to fit. And you have to get in touch with your supplier and talk to the tech guys if you need to know more, and ask for samples. This is really helpful, so you can have your own experience and your own image. And of course, you run your own tests in your evaluation with your own measures, and then you know if the component fits to you. Some say it's too much effort for just a reset switch, or yeah, but this is your decision, of course. Yeah. I could talk about switches all day long, and we could go much further into details. So if you are interested in more details, we will have a brand new customer training about switches very soon, and we go into detail there. So at this very point, I say thank you for listening. Oops. And yeah, if you have any questions, then you can raise it. I will check if there are any questions. And I hope I could inspire in just a short time here a little bit. Even if this may be a minor product on your application, even if it's built from metal and plastic, as mentioned, yeah, a switch looks simple, but the complexity behind is what you maybe never thought about. Yeah. So we at Würth Elektronik also believe a good switch will add up your application, because your end customer will have a better feeling to use the switch and be more happier with your equipment. Okay, so this brings me to the end. And maybe we can see if there are some questions.
Thank you, Götz, for your interesting presentation. Like you already mentioned, we will turn our attention now to the questions. So let's have a look. I think there is already a question. What's about minimum load specifications? How to calculate pull-up resistors?
Mm-hmm. Yeah, that's a really difficult point, and which leads to a very long discussion. You talk about the low-level contact resistance and how to burn away such kind of oxidation on the contacts. So myself, I've not been working with pull-up resistors, so maybe we could talk or discuss this question later and directly, because it's really special. Yeah. What we can give as a standard hint is that you should achieve at least 5 milliamps and about 5 volts. So if you apply this to contact, it will be working securely.
Okay, great. So there is another one. Do you have IP67 main switch?
Yes, of course. Thanks for asking this. Yeah. Just let me show you the web page. I have just to open it. So can you see the web page now? Oops. So
Yes.
hope you can see my screen again. And do you see the web pages?
Yes.
Okay, fine. If we talk about, the question was if we have IP67 switches, power switches, is that right?
Maybe we should turn to the English side. Maybe it's better.
Oh yeah. I'm sorry for that.
No
Here's the
problem.
English one. Yeah. Sorry, if it comes to power switches, we call it rocker switches, and then we have here a brand new one. If it's IP65, not 67, but 65, not to be submersed, but who will submerge its whole appliance, so it's against spray water. And you can easily find this component here. And all the data sheets, by the way, are here. Also the 3D files and so on. You find everything here.
Okay, great.
Mm-hmm.
So thank you very much. We finished now with this presentation. If there are any questions left, we will answer them via email afterwards. Thank you for your attention, and I hope you enjoyed our presentation. I think, yes, the next topic is the impact of contact resistance and plating on the performance of a connector. See you there and enjoy our digital days. Goodbye.
Okay, thank you also from my side. Bye-bye.